A plant soaks up some sunlight on a bright day and is able to grow. A roller coaster treks up a hill and is able to zoom fast down the other side. A cell phone plugged in is able to recharge its battery. Gas, fossil fuel in a vehicle. The vehicle is now able to run its motor, turn its wheels, and drive down the road. A nuclear power plant located near Russellville, Arkansas, provides power to homes and businesses. A candy bar consumed by an assistant to the regional manager gives him energy for another day of fighting crime and seeking justice. What do all of these things have in common with each other? How is it possible that light can cause a plant to grow, that elevation can cause a roller coaster cart to move down a hill, that a battery can give and gain power? What do these things have in common? How are these things possible? Well, they are all examples of the uses of energy. The only way we can explain all of these different things, from eating a candy bar to the workings inside of an atomic nucleus, is to analyze the changes taking place in terms of energy, energy flow, energy transformations, energy being transferred from one object to another. Typically speaking, scientists like to split the universe up into two different components. Matter. Matter is anything that has mass and takes up space. This is what you can touch and feel and hold in your hands, and feel the weight of it. Your dog, your computer, your cell phone, your body, a plant, a roller coaster, these things are composed of matter. But matter is not the whole story. If we are good scientists trying to understand the inner workings of the universe, matter is only half of the picture. The other half of the picture that makes our universe function the way it does is energy. And so this unit, we're going to be studying different types of energy, how energy works, and we're going to learn to see how we can model energy in different ways. Let's begin with a definition of energy. I'm going to say that energy, it is hard to define, but let's define it for now as a quantity. That means a measurement, an amount, so we can measure the amount of energy. A quantity that measures the ability to cause a change in a system. The ability to cause a change in a system. Let's go back to this slide. Everywhere on this slide, we see changes happening. We see electricity being generated. We see a car that was not able to move down the road now being able to move down the road. A roller coaster gaining speed. A plant growing. A body being able to move and function. The vitality, the life of the universe, so to speak, the ability for things to change, the ability for systems to change their state, to change how they are arranged, to change their motion. This is energy. Without energy, the universe would just be lifeless, motionless matter, just sitting around, not changing at all. So wherever there is a change, whether it's a change of motion, whether it's a change inside of a plant that's growing, a change in a roller coaster's speed, you flip a switch and lights come on in your room, you plug your phone in and the battery life increases. Wherever there's change, we have to explain that. We can explain it in terms of energy. Energy is measured in the unit known as joules. We abbreviate that with a capital J. And the big idea, I'm going to go ahead and give you the big idea of this whole unit right here at the beginning. Just like momentum, when we were studying that, energy is also a conserved quantity. This means that the total amount of energy in a system cannot be changed, so the total amount of energy has to stay the same. It has to be conserved. In other words, energy cannot be created or destroyed. Energy can, however, be transferred between objects, and energy can be transformed into different types. These last 2 points are incredibly important. Energy can be transferred between objects. That means that objects can pass energy back and forth, and energy can be transformed into different types. Energy, as we will see, we can categorize it into different types, and energy can be transformed from one type to another. Everything I've just said is a law that you've heard of before, I'm sure. The law of conservation of energy. Energy is a conserved quantity. The total amount in a system cannot go up or down, unless, of course, something is acting um, on that system, something from the outside coming in to act on that system. Remember, the word system just refers to whatever it is that we're studying at the time. So yeah, energy is conserved, just like momentum. Let's start talking about different types of energy. I bet if I were to ask you right now to list some types, you would be able to do so. You would probably say something like electricity. You might say kinetic energy, potential energy, things like this. So I'm just going to run through really quickly the types, and then at the end, we're going to kind of focus right now on a specific type in this course. We will cover others later. The first type of energy I want to talk about is one that we interact with every day. We could not get very far without it. Electromagnetic radiation. That's just a fancy scientific word for light. It's almost a form of pure energy. Light carries energy as it travels through space. It travels through space as a wave. We're going to study light more in our next unit. So this chart probably doesn't make a lot of sense to you right now. That's totally fine. We're not going to focus on it. As we will see, there are different types of light depending on the property of the wave. If it's a really long wave, if the wavelength is very, very long, then we're dealing with radio waves. And then as the wave gets shorter and shorter, we have different types that we classify as visible light. The light that you can see is only a tiny little sliver of all the type of light that's out there. Your eyes have only evolved to interact with a small portion of this spectrum. And the smaller and smaller you can see, we get X-rays, and this right here is gamma rays, which are the smallest waves of light. Light can be thought of just as a form of pure energy traveling through space like a wave, carrying energy with it as it goes. Another type of energy is called nuclear energy. This is just like it sounds. It's energy due to processes that are happening within the nucleus of an atom. We will talk about this later as well, but this is a basic rough little picture of what an atom looks like. Hopefully you guys know that atoms compose all matter. They're the basic building blocks of matter. So every atom looks kind of like this, and the piece inside is called the nucleus here in the middle. It's composed of protons and neutrons, and then electrons kind of dance around outside the nucleus. The nucleus is basically a big storage tank almost for lots and lots and lots of energy. If you fiddle around with the nucleus, you can tap into that energy. And scientists discovered how to do this during the first half of the 1900s. They learned how to split an atom, which is where we got the atomic bombs and things like that. There are two main processes that can occur in a nucleus. A nucleus can be split. It can be cut in half. That's called fission. Or two different nuclei, two different atoms really, can be smashed together to make a larger one. That's called fusion. I think that makes sense. To fuse together means to bring two things and put it together. Nuclear fission and nuclear fusion. Both of these processes release a whole lot of energy. The sun actually undergoes nuclear fusion. That's how it generates so much light and heat. So thank you, nuclear fusion, for sustaining life on this planet. Nuclear energy, it's energy due to processes occurring within the nucleus of an atom. Electrical energy is another type. Very simply, I'm going to say that this is due to the unidirectional or one-directional flow of electrons. So here's a really simple diagram that we are going to look at later. We have a battery that is kind of our electrical source, our energy source, if you will, and it is forcing, it is causing, it is pumping electrons, and the electrons are flowing around in one direction, and we're able to kind of suck some energy out of that, and we can transform it into light energy to light this light bulb. So that's kind of the basic idea behind electrical energy. Thermal energy is another important type of energy. We will be discussing this one. This is energy due to the motion of tiny particles of matter. So we said earlier that everything is made up of atoms, and atoms can combine together. So let's say here's an atom of hydrogen, here's another atom of hydrogen, here's an atom of oxygen. What do we have now? We have water, right? H2O. We would call this thing a molecule when you have multiple atoms bound together like this. So that's what I'm talking about when I say tiny particles of matter. I'm talking about molecules or individual atoms. These things don't like to sit still. They tend to have this kind of pent up vibrational energy where they vibrate and they move around. They can fly around, bump into things, collide with things. And that amount of motion, the amount of motion that those little particles have, is thermal energy, which you probably know of as heat. Do not confuse this with temperature. Temperature is actually a little bit different. Temperature is not a form of energy. It's a measurement of average energy. But thermal energy is the energy due to all the particles moving around in a system. So here you can see that system A here, these particles are moving around a lot, so it would have a lot of thermal energy. System B here, these particles are moving around very little. They're moving slowly, so it would have low thermal energy. And this diagram shows the thermal energy being passed from system A to system B. We will talk about that later, but for now all you need to know is that heat energy, thermal energy, is due to the motion of the molecules or the atoms within the substance. They are constantly moving, bumping around, colliding with each other, and that is called heat energy.